Okay, we're back with part number 2. I have my goggles on because we're gonna do some real dangerous testing. I've connected to the configurator. As you can see, I move left, right. You can see the yaw, you can see the pitch getting negative, which means left roll, right roll. You know, those things we talked about last time. I'll also show you the heading hold if you have that activated. It looks like this quad here, the red little arrow displaying what direction it is. Now it is 30 degrees, now it is minus 50 degrees. Okay, so we have that fixed out. Now we're also gonna confirm the actual stick movement in transmitter adjustment. So just to get this clear, up on pitch is up on that one, left on roll is left on this one, same thing with the other two things. Right, up and down throttle, this is mode I don't know if it's mode 1 or 2, but on my control there is throttle on the left side, and the yaw going left here, yaw going right. The positions of these switches, as you can see here, they are not so important. You just have to get used to what direction they're in. Okay. Last time we checked for acrobatic mode. So if I arm, we have locked to a certain heading, and yes, I turn it left, the regular props go up. I turn it right, the pusher props go up. Okay, so it's locking here. When they're all equal, then the quad will be stable. Okay, move it forward fast. I went through that. Yeah. So now we are going to move into stable mode and check what happens there. I flip the switch to stable mode, and you see now the only one motor is up. This is because I-term is plussing and plussing and plussing if the wrong angle is measured. So but before before stable mode we should go through acro mode. Actually, I'll put on my glasses, we'll switch to acro mode. This would be middle. Okay, and artificial horizon, no matter what it is, because it's just preventing angular speed. So if we look here, if I would run my motors now, it would be level, and if I would tilt it, the left motors would go up, temporary. But the thing is here, if you heighten P, proportional part of the PID, this value read here, the 0 roll, this value will be scaled differently to the motor outputs. So if you have a factor of 1 times 0 roll, then it will act like this. If we put a factor of the double amount, then these ones will get twice the amount of increase. So that's a direct proportional thing. So let's try to raise this to 5. We have roll PID values to 5.3 instead of 1.3. Okay, I'm updating. Let's see what happens now. If I roll it, I expect much more movement on roll. I'll try to level it out here, like there. You see, if it rolls, now it responds really much, because I have 5 for P. Really much on roll. Not so much on pitch, because I didn't put that up so much. Not so much movement, but on roll I have very much movement. You can see a distinct difference between the left side motors and the right side motors. Okay, this is how it's gonna affect. this is gonna oscillate a whole terrible lot. This is gonna move like this, trying to correct very small angular movements all the time. So it's only correcting for noise, actually. It's very sensitive to noise here. I've put my smooth factor to 1, so I'm not filtering anything, but if I would put up the smooth factor a lot, it would regulate too slow. So let's say I put in the smooth factor area, put 0.01. Okay, I had 1 before, I've got to remember that. And we're just looking at Euro roll, so take away every other factor. Okay, and pitch angle. Yeah, remove. So now we're just watching it like it is. You see, it responds pretty nice to us, but the quad thinks it's all too slow. Left goes down, right goes up. Okay. If I would put it up to 1.0 again, 1.0, then we would see much more movement when we think the quad is like still, and you see it responds much faster. This is what we need. We also need to tune this so no noise, no excessive noise comes in. So you might wanna have to put it to 0.9, 0.8 or something like that. But I can fly with 1.0 because I have mechanically removed enough vibrations. Okay. We can't fly with 5.3 on roll axis. I'll put in 1.3 again. Okay. If you put it below 1.3, like 0 or 0.1, then it's not gonna counteract your external disturbance, because if it's moving with a very great speed, it's not gonna do much. Okay. So you need to find a balance, both in the filtering and the P value. The D value is just for fine-tuning. Use it moderately and experiment a lot. But when we're getting to stable mode, we get a total another reaction. I have put in 1 for P and 0.8 -8 for roll rate. Okay. Those you should be able to fly with these values, 1 and -8, just those for stable mode, because that, and put roll axle and pitch axle to 0, I and P, because that is just exactly like flying in acro mode. And then you can start adding P to roll axle and pitch axle and see how that affects, but only add small amounts like 0.5 to begin with, to see what it does to the process. Okay, the interesting thing now is if we calibrate it and zero out the I, the integration term, we will get level motors. So I'm disarming, I'm calibrating. As we can see now, artificial horizon is calibrated. I put the quad here, it is level. Okay. Now, if it is totally level, it shouldn't add or subtract anything to the actual motors when I start them. As you can see here, they're going up level, but if I move the quad backwards, they're slowly gonna increase or decrease by time. I move it forward, you can see them moving slowly. Okay, so what I told you is, if we're in stable mode and we have integral term, it will slowly add or subtract to get to this desired angle. So let's say I move it backwards, then the front motors will get lower and lower, and you can see it's very low now. I move it the other way, they should get higher, higher and higher, this angle, and they get higher and higher and higher. I'll try to zero it again. Okay, I go up to middle, I move it forward, they should get higher and higher, backward, they should get lower and lower and lower. This is because of I. If I put I from, I have 9 now, to 0 on I term, this shouldn't happen at all. So we're zeroing it and we're starting with level. Okay, you can see now that they're about level. I put it forward. Now we don't expect the forward motors to constantly rise. We just expect them to rise one time, proportional to the angle, the position. So backward they go down, they stay, because I only have P for angles, or roll axle and pitch axle. Okay, forward they get to a constant value according to angle, backward they got to a constant value. I add on 5 for I, and it won't rise as fast. This controls speed, it corrects for angle. Okay, so now I have it. I am zeroing in and starting again. I move the front motors down. Slowly they will get up. Yes, now they're up. Okay, I move it back. Slowly they will get to the other direction, because you don't want them to speed up, you want them to speed down. If they have sped down like this, then the quad will behave like this, going forward, and they will slowly get to a higher value. As you can see, they're going pretty slowly. I have 9 for the I term. You might wanna experiment much on that. It's depending on time, very much on time. I'm adding in a loop in 500 Hz, but the sensors are just updating in 100 Hz in my case. Now it's locked to the front motors being high. You can actually simulate this. If you look at this, you see that the front motors are very strong. If the front motors will be very strong now, the quad will behave like this, going wildly up. And you can see what happens. You can simulate it by looking at the back left motor. Back left is doing much now. Okay, then it should go down if the quad actually goes there. If I do what the configurator tells me, it tells me much on rear left. I go up much on rear left. Now it is very low. So that's the way you can check out that it's doing what it's supposed to do. Also, you should check out what the stick movements does. Pitch up, the front motors will get down and the rear motors will go up. And if I roll it to the left motor should go down, the right motor should go up. And you can confirm by actually leaning this to the side that the motor commands says. That's tuning, I hope.